So we stopped. You can see my screen, right?
Yes.
Good. So I left you an exercise here to do. I hope you have tried it. You are supposed to find the image of a point 1, 2, -3 under the reflection through this plane. So basically, you have to find this vector that is you have to find this point and another point on the other end, which is the same distance from the plane. So this point is not really 1, 2, 3. It's the image of A under this reflection. So this is a point you're supposed to find. You work it out and let me know. Now we want to check how do we know if two lines are on the same plane? So that's what we mean by coplanarity. So how do we know when two lines are on the same plane? So this is true if the following relationship holds. If these are the two lines, then if the determinant of this matrix is equal to 0, then it means the two lines are on the same plane. Are we together? So you can see from this. So basically, this is what appears here is an illustration of this. You have two lines. This is the first line. That's the second line. If they're on the same plane, you can pick a point on this line and another point on that line and create a vector which we call W. Now, if they're on the same plane, it means the volume formed by the parallelepiped determined by the three vectors should be 0. And that volume is this, W dot D cross D prime, where D prime is this for line, the vector on this line, and D is a vector along the other line. So you can see if you get this as 0, then your work is done. It means the two lines are on the same plane, because it's just the volume of a parallel pipe formed by these three vectors, and that will be 0 if they're on the same plane. So here is an example. We just apply the same ideas. The example says show that these two lines, x plus 3 over -3 is equal to y over 2 minus y minus 2 over 4 is equal to z minus 5 over 5. Then x plus 1 over minus 3 is equal to y minus 2 over 3 is equal to z plus 5 over 6. So I can see a comment from Omolo. I will put this on SOMAS today. I've already shared the notes already, but I will put them on SOMAS again. I need to know if you can hear me. John, you can hear me?
Yes, we are hearing you.
Okay. Everyone is too quiet. So, and you can also see the screen. Eh?
Yes.
Good. So if you apply the ideas we had above, you need to pick 2 points on each plane. So this point, -3, 2, and 5 should be on this plane, right? and this other point as well, -1, 2, and -5 should be. No, it's not really on the plane, but it's there are these points. You see x1, z1, and y1. Then you have x2, z2, and y2. So we're just picking those points, and we're going to plug them into this matrix and get a determinant. And that's exactly what we do here. And we get the determinant is -12. Now the determinant is not 0, so it means that those two lines are not on the same plane. If the determinant was 0, then they would be on the same plane. So let's move on to the next. The next one says we need to find the distance of a point from a straight line. So, so if you have a point in space, and that is your straight line, the distance from this point to the line will simply be this projection of this point A onto the line. So L here is a foot of a perpendicular that is drawn from A to the line that is of interest. So that distance, from A to L, will be the distance we are looking for. So we're going to describe what is there. So L is a foot of a perpendicular from A to the line. The coordinates of L will take this form: alpha plus TL, beta plus MT, and gamma plus NT for some T in R. Now, why do we say this? Because this is the equation of the line, right? This is the equation of the line. So it means the line is parallel to L, M, and N. I mean this vector L, M, N. And you can write in the equation in parametric form. So the X value will be alpha plus TL, the Y value will be beta plus MT, and the Z value will be gamma plus NT. Now this is the equation of this line. It's the equation of a line that goes through the 2 points A and L. And since L is on that line, then its equation, it is possible to find a value of T such that this will be the point L. So the coordinates of L will definitely take this form, which is just a parametric form for the straight line. Now, so AL is perpendicular to the direction cosines of these vectors, L, M, and N. Right? You see, there's this line. We have set up the equation of this line. I think I made a mistake here. The equation we have here is actually the equation of this line. Not the equation of the line through A and L. It's the equation of this straight line of interest. Right? But the point L happens to be on that line as well. So its coordinates must take the same form. That's how it is. So the vector AL is perpendicular to this line that is parallel to our straight, this vector that is parallel to our straight line. And therefore, the dot product of AL and this vector should be 0 because they're perpendicular. So AL, we know the coordinates of A, and now we have a way of writing the coordinates of L. So we can get the position vector of this vector from A to L will be given by this alpha plus LT minus X1 as your first component, then beta plus MT minus Y1 as your second component, and gamma plus nt minus z1 as your third component. Then you get the product of this AL with mn and you work it out. This is what you will end up with. And that should be equal to 0 because the two vectors are perpendicular. So now from this, we can, once we have it in this form, we can find the coordinates of L once you obtain T. If you simplify this whole setup here, you will have to take your time and do some work here. Try to make T the subject of this expression. You should find that T is equal to this, right? And once you find T, then you can easily obtain the coordinates of the point L. Yeah. So that distance, once you find the coordinates of the point L, you can find this vector AL, and the distance that you'll be looking for will be the magnitude of this vector from A to L. So here is an example. Find the distance of a point 593 from the straight line. X minus 1 over 2 is equal to y minus 2 over 3. So if L is a foot of a perpendicular line, then it's possible to write the coordinates of L in this parametric form, as we had seen in the explanation above. So this is just a parametric form of this line. And since L happens to be on that line, we can write its coordinates in that form. And now get the vector AL. This will be the vector, the position vector for the vector AL. You'll obtain it like that because you know the coordinates of A are, I think they are 4, 7, and 0. Is it correct? No, 5, 9, and 3. So when you subtract and simplify, you should get this. 2t minus 4, 3t minus 7, and 4t. So that means the dot product of this and the vector that is parallel to our line, the vector that's parallel to our line will be 2, 3, 4. It should be 0. So you get the dot product of those two and equate to 0. And when you solve for t, you will find that t is equal to 1. So that means you can come back and replace t here to obtain the coordinates of L. And you will find that L has the coordinates 3, 5, and 7. So what was of interest was the length from A to L. So this vector itself, the position vector for this A to L will be minus 2, minus 4, and 4. Is that correct? And then the magnitude of this should be the square root of the sum of the squares of these things. So here we have, if you square this, you have 4. You square this, 16 plus 16 plus 4 will be 36. So the square root of that should give you the magnitude of this vector, the square root of 36. But this one, you know how to compute the magnitude of a vector. So I think this should not be a problem. That's why I've left out the details. You have to compute the magnitude of this vector. You should get it to 6. So that means the distance from this point A to the line L is from the point 593 to this line is 6. So the next thing we look at is the shortest distance between two straight lines. So it says if two straight lines are coplanar and parallel, then the shortest distance between the lines it's easy to obtain. It's the same as the distance of any point on one of the lines to the other line. So this will be easy to compute. You'll do exactly the same thing we have done when finding the distance from a point to a line. So you just need to find one point from one of the lines and find the distance of that point from the second line. And that will be the distance between two parallel lines. And being on the same plane, that is important, if they're on the same plane. If they are not on the same plane, then that may not work. So we have other options. If the two lines are parallel, this is how you obtain the distance. If they are not parallel, then they can be skew. So they can be on, two lines may lie on parallel planes, right? So this is a plane, and we have a line that is on that plane. This again is a plane, and we have a line that is on the second plane here. So the two planes are parallel, but the lines that are on these planes are not parallel. So we call this kind of lines skew. So they do not intersect because they lie on parallel planes, but the lines themselves are not parallel. So we call them skew lines. So our interest now is to find the distance from between these two skew lines, from this point, that point. So the shortest distance. And there'll be only one point on each line, which will give you the shortest distance. So what we'll realize also is that this line of shortest distance will be perpendicular to both lines, right? So take note of that. So if the lines are skew, we suppose that they are parallel to the vectors d1 and d2. Then the line of shortest distance will be perpendicular to these two vectors and therefore must be parallel to the cross product of these two vectors, right? If you go back here, if these are the two vectors that are in the same direction as the lines, then their cross product will be a vector that is perpendicular to both lines. So this line is perpendicular to both lines and therefore is in the same direction as is parallel to the cross product of the vectors that are in the directions of the lines. So this we have established that the shortest line must be parallel to this vector. So if you pick if A is a point on the first line and B is a point on the second line, then the shortest distance is a projection of the segment AB onto the line of shortest distance. So we can illustrate this. So this blue line, assume this blue line is a line of shortest distance. So if you pick any point A on one of the lines, another point B, then this shortest distance is simply the projection of this vector onto this line of shortest distance. So basically, it's a projection of this vector AB onto a unit vector in this direction of the line of shortest distance. So if you are to find, once you find this cross product of the vectors D1 and D2, then if you have any 2 points, one on the first line and the other on the second line, you can create a new vector AB and find the projection of that vector onto this cross product. And then you will have found the distance. That projection will be the distance. So let's assume that we have two lines. There's this line here and this one, and we assume that they are skew. They are skew lines. Then we set up D1 to be this vector, the vector that is parallel to the first line, and D2 to be this vector. That's the vector that's parallel to the second line. And we can pick 2 points, one on the first line, that is A, and B to be from the second line. So if you know how to work out the cross product, so the cross product of D1 and D2 will simply be equal to this. You can check this from your vectors. So the position vector for the cross product will just be this. If you work it out, you will get this. So now we need to find the projection of AB on D cross D. And that will simply be the dot product of this vector AB and the unit vector in the direction of D1 cross D2. So this is the unit vector in the direction of D1 cross D2. If you get the dot product of that and AB, you will get the distance you're looking for. So that is worked out here. And this this is now how you work it out. If you get the dot product of a vector and the cross product of the two vectors, remember, this is how you obtain it. This one is just a constant, so it can jump out. This magnitude of D1 cross D2 is a constant, so it can just be brought out, and you work out the cross product of this vector, the dot product rather of this vector, and the cross product of D1 and D2. When you work this out, so this will be another, so if D1 cross D2 is LMN, suppose you work it out and find that the cross product of D1 and D2 is just LMN, then the equations of the two planes that intersect along the line of the shortest distance will be given by x minus x1, y minus y1, why is this the case? Oh, okay. This second bit gives you the equations of the two planes that intersect along the line of the shortest distance. So this will be the first plane, and this will be the second plane. So this last part is simply giving you the equations of the two planes that will intersect along the line of shortest distance. Here already we have found the shortest distance. This projection is the distance that you're looking for. So here we already found it. The next part simply finds the, so what happens is this, if you go back to this diagram, there are two planes that will intersect along this line. One will be the plane maybe that is perpendicular to the second plane, but it follows this direction of A, and the second plane will be the one that goes in the direction of B, and they will intersect along this line of shortest distance. So those two planes are the ones we are obtaining at the bottom here. The equations of those two planes will be this. Not this one at the bottom. Okay. So let's do an example. Find the shortest distance between the straight lines. There are these two straight lines. This one here. And then you need to show that these lines are not skew. So the two vectors we need that are in the directions of the lines are D1 and D2. We can obtain them here, 2, 3, 4, and 4, 4, 5. This is obtained straight from the equations of the line, the symmetric form. So we already have D1 and D2. We can obtain the vector that is perpendicular, the unit vector that's perpendicular to both lines. That's D1 cross D2 over its magnitude. And when you work that out, you should get this as your answer. So you already know how to do the cross product. All you have to do here is work out the cross product of D1 and D2. Once you work it out, work out the magnitude and divide by the magnitude. Then you'll get this unit vector in the direction of D1 cross D2. So the unit vector that is perpendicular to both lines. So we have 2 points on the line. One of them is 1, 2, 3, and the other one is 5, 4, 5. We obtain that straight from the equation. So this point 1, 2, and 3 are definitely on the line. And the point 5, 4, and 5 also will be on the line. So we have 2 points, points on each, 1 point on each line. We can find the vector from A to B as this. And now the distance between the 2 lines will be the projection of this vector AB on this vector in the direction of the line of shortest distance. And when we do that, we find that the projection is 0. So that means the lines are not skew. They must be, they definitely intersect. They are also not parallel. The shortest distance is 0. It means they have a common point. They intersect. If they are skew, they will not intersect because they will be on 2 separate parallel planes and there's no way they can intersect. So here is an example. Find the shortest distance between these 2 straight lines. So you have these 2 lines. And then we also need to find the equation of this line of shortest distance, the line that goes through the shortest, the line that goes through those 2 points of the shortest distance. So again, I will not spend too much time on this. We can obtain D1 cross D2. This gives you the direction of the line that is of shortest distance, where D1 and D2 are these, right? 3, -1, 1, and -3, 2, 4. We can find the magnitude of D to be 3 multiplied by the square root of 30. You can verify that. D is already up here, so you just find its magnitude. It should be the magnitude. So A and B, we pick 2 points on each line separately, and we work out the vector from A to B. The vector from A to B is easily obtained, and you get the dot product of that. And this gives you the projection of that vector onto the line of shortest distance. And that projection is what gives you the distance that you're looking for. So you end up with, when you work this out, you end up with the distance as 3 times the square root of 30. So now we need to find the equation of the line of shortest distance. And that will be the intersection of these 2 planes. So the intersection of these 2 planes will give you the line of shortest distance. So these 2 are obtained from the formula we set up earlier. Remember, this is the 6 minus 15, 3 is the vector D1 cross D2. And this is the vector D1 cross D2 also. So this is now the vector that is parallel to the second line, and this is a vector that is parallel to the first line. So these 2 equations give you the two planes that intersect through the line of shortest distance. So once you work out these two planes, you will, the intersection is the line that you are looking for. So you can leave it in that form. So these two planes, the intersection of these two planes, or these two planes actually represent the line that you're looking for, the values of the x, y, and z that satisfy these two equations will give you the line that you're looking for. And it's okay to leave your answer in this form, the two planes. You say that these two planes, it's the intersection of the two planes that will give you the line. If you want, you can go further and find the actual equation. But for our purposes, this is sufficient. So I think this will complete our work on lines and planes. So the next thing we'll look at is spheres. So I will close this. Unless there are questions on this, I will close it and bring up the slides on spheres. Any questions? Iko swali? So that means you are ready for the cut. Hmm? We can use the second hour to do a cut, sindio? Naona mmenyamaza wote. Eh? Things have gone hot now.
Aye. Ati the second hour.
Yes. Si mnaonekana mmeiva kabisa.
No, Nick's cross.
Hapana.
Mmeiva?
Bado.
Okay.
Ndio tujaelewa.
Okay, but amuulize swali.
Tusome tuelewe kwanza.
Okay. Let's move on to the next topic then. I'm going to close this file, then I open the other one. So now, can you confirm that you can see the slides?
Yes.
Okay. So now we move on to another object called the sphere. So the first thing is to establish the vector equation of a sphere. So there are two things you need to set up a sphere. You need the center and the radius. So if we know the position vector of the center, we call it this vector A, and we also know the radius, we call it rho. Now any point on the sphere will be represented by this position vector R, and we can obtain the sphere is basically determined by this equation. The distance from any point on the sphere to the center must be equal to the radius. So this is a vector equation. You get the magnitude. This vector from any point of the sphere to the center, that distance must be equal to the radius. You can put this in vector form. So if you have the, if you get the coordinates of the position vector of any point on the sphere, that should be x, y, and z. And let this be the center, alpha, beta, and gamma. So this is a fixed point. A is fixed, but this other point varies. A is fixed because it's the center. Then the distance from R minus A will be given by this quantity here. You know how to do that? The distance between 2 points. So you're just getting the distance between these 2 points, x, y, z, and alpha, beta, gamma. That is this. The actual distance should be the square root. And this, if you get the square root, then on this side, you will have the radius, just rho. But since we have omitted the square root, on the right-hand side, also the radius will be squared. Are we together? Hey, wazee, tuko pamoja?
Yes.
Okay, so if now you write it in terms of coordinates, this becomes the equation of a sphere with radius rho and centered at the point, at this point A, with the coordinates alpha, beta, and gamma. So I think this is straightforward. So if you expand this, you will observe that x squared, y squared, and z squared will have the same coefficients. You can see that in the expansion. If you expand the equation fully, this is what you get. You get x squared plus y squared plus z squared minus 2 alpha x minus 2 beta y minus 2 gamma z, and then plus alpha squared plus beta squared plus gamma squared minus rho is equal to 0. So the important thing for a sphere is to note that the coefficients of x, y, and z are the same. They can be different from 1, but even if they are, then they should be the same. We shall see examples where the coefficients are not 1 later. So also, you observe if after the expansion, you don't have any cross product terms. There are no terms that involve xy or yz or zx. None of the terms here are of this form. So there are no cross product terms in the equation of a sphere. You might find this in the other, we shall be looking at some the quadric surfaces, and there you might find some of these cross product terms. So you can simplify, if you look at this equation up here, you have x squared plus y squared plus z squared. Then you have some expressions in terms of x, y, and z here. And then what is left here is just a constant, right? So it means you can simply rewrite this equation as follows: x squared plus y squared plus z squared plus these equations, these expressions in terms of x, y, and z. And then the last term is just a constant. You can put them all together. And then the equation of a sphere can then be represented like this. And then the center will be minus u minus v minus w. So if the center is minus u minus v minus w, then what appears in this equation as negatives, they'll become plus now. Because if this is a negative, minus and minus becomes a plus. That's what that's how we set up. So the radius will be given as u squared plus v squared plus w squared minus d. You can do that by completing the square. You know how to complete the square of a quadratic equation? Yes, John?
Yes.
Yeah, so you can complete each. You see you have x squared and 2ux. You can complete that one. So to complete it, you will need to add u squared, right? And to complete the one for y, you will need to add v squared. And to complete the one for z, you will need to add w squared, right? And when you add them, you must subtract them again. And then when they move to the left-hand side, when they move to the left-hand side, they will definitely be the radius, or the square of the radius, rather. And their square root now will be the radius. So when you complete the square, this is exactly what you get. Down here, this is what you get when you complete the square. And then when you put all the constant terms on the right-hand side, this becomes your radius. So if you look at this, this is precisely the equation of a sphere, where the square root of the term on this side is a radius. So you can see that by comparing it with the equation of a sphere, which we got earlier. So the equation of a sphere looks like this. Here, you can see the term on this side is a square of the radius. If you're able to write the left-hand side in this form, the term that appears on this end will be the square of the radius. So that's what we have done for this part. When you complete the square, you're able to write it in this form. The center will be minus u minus v minus w. And whatever appears on this right-hand side is a constant. And it is the square of the radius. I hope that makes sense. If it doesn't, you can ask questions again later. So if the radius is 0, we call it a point sphere. So it's just a point. If the radius is 0, then our sphere is just a point. So there is another option of finding the equation of a sphere. If you know the two endpoints of any diameter, you know you can set up the diameter in multiple ways. But if you can fix one and find the two endpoints of the diameter, then it's possible to work out the equation of a sphere. So let's pursue this and see how far we'll go. If you have the 2 points as A and B as the ends of the diameter, and then you set up this point P, X, Y, Z to be any point on the sphere, which is different from AB, then the 3 points A, B, and P will lie on a circle, right? One of the, if you did this in high school, the navigation, you know, the great circles. So the point A, B, and P will lie on one of the great circles. So the points A, B, P are concyclic. Concyclic means they're on the same circle. So this word here means on the same circle. So if they're on the same circle, any angle subtended on the circle by the diameter will be 90 degrees from your geometry. And that forces this angle, APB, to be a right angle. So let's see if we can draw that. So this is an attempt to draw the sphere. So this is the point A, and that's the point B. So the diameter runs from A to B. So try to think of this as a sphere, not a circle. Then if you pick any point P, let's assume the point is on the other side, P on the sphere. Then these 3 points, A, B, and P will form a circle, but the circle will be a circle that lies on the sphere with the same diameter as the sphere. So that forces this angle to be 90 degrees. And that means these two lines, AP and PB, are perpendicular. So how you get the equation is simply by getting the vector AP and the vector PB, and their dot product should be equal to 0. With that, now you can get the equation of the circle. So let's see how that works. So you can get AP. This would be the coordinates for AP, or rather the position vector for AP, x minus x1, y minus y1, z minus z1. And on this end, you'll have the position vector for PB, I think. Since the two vectors are perpendicular, their dot product should be equal to 0. When you work out the dot product, this is what you get now. So your equation for the sphere will look like this. So this completely determines the equation of a sphere. If you have the 2 points of the diameter, then this equation is, you work out this equation and you have the equation of a sphere. You can expand it further if you like after working it out, so that you have it in the standard form, but this will be the equation of a sphere. So this other one is just the vector form, the equation. And also this is another one which describes, you can find the center. If you set the vector for the position vectors for the two endpoints of the diameter to be A and B, then the center will be the midpoint of the diameter, which is given by this. So the position vector for the midpoint will be A plus B over 2. And the radius will simply be half of the length of the diameter. And you can also write it out in vector form now. So the distance from this, any vector on the sphere, any position vector on the sphere, and the center should be equal to the radius. So this is another vector form of the equation, if you want to write it in that form. So here's an example. The example says, find the equation of a sphere whose center is 1, 2, 3, and the radius is 5. So I think this one is straightforward. You just work it out like this. You can, if you like, you can expand it and you have it in this form. So both of them are correct, either this equation or that equation. There are situations where you may need to put it in this form. If you need to do any further calculations, sometimes you may need to put it in this form. But any of the two will work. Any of the two is correct as the equation of the sphere. Is this one making sense? This example?
Yes.
Good. So now here is a question for you. Find the center and radius of the sphere given by this equation. So I will give you this as an exercise, and I will give, nobody from yesterday claimed the 50 MBs. I think I can keep them. So let's see if someone will claim today. Or did anyone claim? Or the people who won are not here? So can you solve this one? Find the center and radius of the, write down this equation, then I can take you back to the section which helps you to find the center and the radius. Just write down this equation in your books. Then I will scroll back to the slide where you can, which has the information which you can use to find the center and the radius of the sphere. So I think you have now finished writing it. I'm going to scroll back to the part which can help you solve this problem. Then you, once I get there, you solve that problem. So where is it? I think it's a little higher up. I think this is a part. So you need to identify all these parts of the, so this will help you solve the problem. The first person to solve, you will get the 50 MB. How many minutes do you need? 1 minute? Is there anyone in class? No one is talking. Ama mmewasha kompyuta mkatoroka?
No.
Hapana.
So let me give you 3 minutes to solve that one. 3
Yes.
minutes is enough.
Yeah.
Excuse me, mwalimu.
Because Wally,
Yes, would you kindly scroll so that I look at the equation again?
the question. So,
Yeah,
but do you have this part?
yeah, I have the one on the screen now.
Okay. So if you have taken it down, I can scroll back to the question. Here. You can see it now.
Yes, I can see it. It's the same one I have. Thank you.
Yes. So should I go back to the?
Yes. The slide that you want.
The part that will help you to solve. Okay. So you need to, I'll just make this. So there it is now.
Answer, teacher.
Oh, you have the answer?
Yes.
I have the answer.
No, the first person who said, let's go to what a line here.
I have the answer also.
If you have the answer, you tell me. The first person, who was it? I don't know who it was.
It's me.
What was your answer? What
2
was the
negative The center is
Mhm.
2,
Mm-hmm.
negative 3 over 2,
Mm-hmm.
1.
Yes, and the radius.
The radius is root 19 over 2.
Yeah, that's correct. So you are officially the winner of the 50 MB.
Yes.
Does everyone understand how that works?
I'll win it, sir.
Huh?
By 2. Hapa. Itakaza itakuwa 2.
So you just need to look at this equation and compare it with so once you look at this, you compare it with the setup we have up here. So you need to identify the value of U, V, and W, and D as well. So just compare this with the equation that you have and identify all these values, U, V, and W, and that will give you the radius. The square root of this is the radius. Hey, what is going on? What is going on? Are you slaughtering some chicken? Hey, yawa. Where?
Excuse me, sir.
Yes, Mukali.
Pardon what you have said.
I repeat again.
Yes.
So, what exactly have you missed? Do you have the equation? Have you written down the equation on your book? In your book?
Yes. Yes.
Yeah. So if you look at the equation, you have to compare it with this one. Are you following?
Yes, I'm following.
So if you compare it with this equation, what is the value of U? I need you to answer. Just look at the equation you have and compare it with this. So you need to compare and figure out what is the value of U. So the coefficient of X is 2U. So look at the coefficient of X in your equation. That will be 2U. And then from there, you'll be able to find the value of U. Are you following?
I'm following.
Yes.
But I have a question.
Yes. What is the question?
This equation by 2.
Pardon?
Do we in our equation, the question that you have given us, will you divide all over everywhere by 2? Because like if an here.
They don't need to look alike. You just need the coefficient. Compare the coefficients. The coefficients must be equal. So if this one says 2U, you go back to the equation. Here the equation is what? Where is it? Here. So the coefficient of X is what? It's -8, right?
Yes. Yeah.
So that means 2U should be equal to -8. Is that correct?
Yes. 2 is equals to 8.
So that U will be equal to, is that correct? Oh, no. I think we simplified the equation.
Yeah, that is what I'm telling
Yeah,
you.
we simplified to divide throughout by 2 so that it looks like the other one. Yes.
Yeah.
You have to divide throughout by 2. Which is exactly what we have done here. So once you have it in this form, then you can compare it to the equation, so that now you will not be comparing this one. It is this one now that you will be comparing. Right? So that 2U will be equal to -4. Are we together now?
Yeah.
So now you don't have any more questions. Your question is answered.
Yes, I'm okay.
Good. So the next problem says you find the equation of a sphere which has these 2 points, 3, 1, 2, and 1, negative 1, 2, as the ends of the diameter. So again, I want you to solve this one. Another 50 MB is on the line for this one. And the person who won the first 50 MB, please make sure you claim so that I remember.
Yes.
So now solve this next one. Write down the question. I'm going to go back to the point, the section which will help you to solve this. So this is a diametric form of the sphere. So I think by now you must have copied the question. I can scroll back to the section with the theory. So I think this is a section with the theory. So it is here. Yes, Joel, you have a question?
Answer.
Or you have the answer?
Yes.
Okay, so let's go back to the question. What is the answer?
The answer is x squared plus y squared plus z squared minus 4x minus 4z minus 2 is equal to 0.
That's correct. So what is the radius of this circle or of this sphere? So that's correct. You already qualify for the 50 MB. But now I need someone to tell me the radius of this circle. So another way you would have solved this is simply to find the center of this, the line joining the two ends of the diameter. That's easy to find the center because you know the endpoints. Once you find the center, you have the coordinates of the center. Then you can also find the radius. The radius is just half of the length of the diameter. You can find the length of the diameter. And once you have those 2 points, again, you can solve this problem. So there are You can use this formula, or you can do it the other way I mentioned. So is there anyone who has not understood this? Inaonekana imeelewa, so hii tufanye cut saizi. So here is another example. The example says, find the equation of a sphere passing through the 4 points, these 4 points, 0, 0, 0, 0, negative, 0, 1, negative 1, and so on. So what this means is that all these points are on the sphere, and therefore they must satisfy the equation of a sphere. So we will answer it as follows. We set up an equation of a sphere. The equation of a sphere will look like this. We don't know what the values of u, v, w, and d are, but we will try to find them. We use the fact that the points are on the sphere. So if you substitute the first point, which is 0, 0, 0, everything here will be 0 except d. So that's what you have. If you take the other points and put them in the equations sequentially, you end up with these 4 more equations. So the first one clearly tells you that d is equal to 0. The second one there's a 1 here. Since if d is 0, this 1 plus 1 will be 2. So the second one, after simplification, you will see that it says v minus w rather is equal to negative 1. If you simplify the third equation here, you will get u minus 2v is equal to 5 over 2. And if you simplify this last equation, you should get u plus 2v plus 3w is equal to minus 7. So now if you solve this system of equations, it's a system of 3 equations in 3 variables. These will be your answers. You'll get u. D is already known, so d is 0. We don't need to bother with d. We just solve this system to find u, v, and w. So once you find u, v, and w, then you can put them back in the equation and set it up like this. This becomes your equation. So this is the equation of the sphere that passes through those 4 points. Now you can multiply throughout by 7 so that you get rid of the fractions if you want. Then you'll have 7x squared, 7y squared, and 7z. So this gets rid of the fractions completely. So like we said earlier, the important thing about the equation of a circle is that the coefficients of x squared, y squared, and z squared must be equal. So this is just fine. So you can move from this form to this form. You simply multiply throughout by 7 to get rid of the fractions. So let's move to the next part. The next part talks about the points and spheres. So if you have a point, how do you tell if it is inside or outside a sphere? So let's set up the equation of a sphere here and pick any point in space. Now, we can tell if this point is outside the circle, the sphere, not circle. I don't know why I've written circle here. This should be sphere. It should be outside the sphere if a distance from the point to the center of the sphere is greater than the radius. Right? So if the distance from that point up to the center is bigger than the radius, then that point is definitely outside the sphere. A similar logic applies to the second one. If the point is inside the circle, then the distance from that point to the center of the circle must be smaller than the radius. So that's how you tell. So we can use this information to come up with some expressions. So we know that the center is minus u minus v and w. So the distance from the point to the center, and this is the radius. So we have two, I've combined the two. So the top one shows that the distance is greater than, then there's a red line here. Then the second equation says the distance is less than. So the top one takes care of this first situation, and the second one takes care of this second situation. That's why I've labeled them 1 and 2. So this top one is 1, this second one is 2. So this distance, if it is greater than the radius, then the point is outside the circle. If it is less than the radius, then the point is inside the circle. So when you simplify this, this is what you end up with. When you work it out and put all the like terms on one side and so on, the u squared on both will disappear because they appear on both sides. When you switch sides, this is what you will end up with. That this expression should be greater than 0 if the point is outside the sphere, and it will be less than 0 if the point is inside the sphere. So if you have a point and you want to check whether it's inside the sphere or outside, all you have to do is to plug it into this equation, the equation of the sphere, which is up here. If you plug the point into this equation and you find that your answer is greater than 0, then that point is outside the sphere. If you put the point in this equation and you find that the answer you get is less than 0, then that point is inside the sphere. So all you have to do is plug the point into this equation and see what answer it gives you. If it's positive, if greater than 0, then the point is outside. If it's negative, that is less than 0, then the point is on the inside. So so here you have some work to do. You need to sit down and expand this and try to simplify to this. At this top part is simple. You're just getting the distance from the point to the center. And on this side, you're just comparing with the radius. So between this equation and this last one, you have some work to do. So better sit down and do some work. Expand this and simplify to this. Once you bring everything to the left-hand side, you will end up with this. So here's an example. Can you quickly determine can you tell me which side of the sphere is this point? 1, 2, 3. The sphere is given and the point is also given. So I'll give you 1 minute to quickly work that out. Mmemaliza?
It's greater than 0.
It's greater than 0.
Yes.
Okay. Let's see if you are correct. So I also got 22, which is greater than 0. So this point is definitely outside the sphere. So let's try now to connect lines and spheres. I think we have a few more slides to go, then we are done. So lines and spheres. So if you're given a sphere and a straight line, there are 3 options that can happen. We have tried to draw them here. So you can have this situation where the straight line cuts the sphere in 2 distinct points. If that is not the case, you can have the situation where the straight line just touches the sphere at exactly 1 point. Then there's this third situation where the straight line does not touch the sphere at all. So in projective geometry, if you study projective geometry at some point, even this last option has some points of intersection. Again, you don't need to know that. So again, simply ignore what I have said again. I'm leaking some information for you. If you study geometry to a higher level, you will see that this line and this sphere will still intersect, but in a different space, no, not the Euclidean space. So we shall focus on these two, just these two, where either the line touches the sphere at exactly 1 point, or it cuts through the sphere, cuts the sphere through 2 points, 2 distinct points. So those are the 3 options you have anytime you have one line and a sphere. So these diagrams are not so good, so I will have to demand that before we proceed, you must believe that these diagrams are spheres. Do you believe they are spheres?
Yes.
Okay, so now if you believe, we can proceed. So let's the equation of a straight line be given by this. It's given in a symmetric form. And then we have the equation of a sphere in this form. So we need to find the points of intersection of these two. So to find the points of intersection, we'll write the equation of the line in parametric form. Yeah, so if the point for it to be a point of intersection, it must satisfy the equation of a sphere. So we can just pick these coordinates and plug them into the so let's continue. So if this point is on the sphere, then it must satisfy the equation of a sphere. So for us to find the point of intersection, we can plug in these values into the equation of a sphere. These values of x, y, and z. From the line, we plug them into the sphere. And when we do that, we have a long calculation that eventually ends up like this. So what you have here is just a quadratic equation in t. So these are the coefficients of t squared. This will be the coefficient of t, and whatever is left will be the constant term of the quadratic equation. So if you solve these for values of t, the values of t that you find will give you the points of intersection. So the values of t that you find, you can plug them back into this parametric equation of the line, and you'll be able to find the 2 points or the 1 point of intersection. Are we together? So again, there's some work for you here. you know, the rules say that the teacher should do only 25% and the student should do 75. I think that's a fair deal. So silence means you agree it's a fair deal. Or you can give me 15, I give you 85.
50-50.
Hey, bwana. Sasa, okay. Anyway, now the work you have to do now is simple. It's not too much. If you expand this and simplify and write it in terms of the as a quadratic equation in T, you should be able to get this. So if you want to move from here to here, there's some work in between. You have to expand all these squares and put all the coefficients of T together here, and also put all the coefficients of T squared here. And anything that is left that does not involve T comes at the end, and that will be a constant for the quadratic equation. So all these values are known. Here they look long, but when you work them out, this one will just be one number. This one will also be just one number. And this L squared plus M squared plus N squared will also be just one number. So let's do an example. Or maybe I can give you this as an exercise. Find the points of intersection of this straight line and this sphere. I'll give you 3 minutes. So maybe you can write down the question, then I'll go back to the section with the theory. Nani amemaliza?
We try.
You want to try?
Yes. Oh, my answer is a few.
What do you have as the answer? The point is?
I've got like 2 into brackets.
No, we just need the point. The only thing required here is 2 points or 1 point, depending on what your answer will be. So I need the 2 points. That's the final answer. You need to have it. Have you finished? So let me go back to the setup. This is what you need. So you don't have to start from here. This might even be longer. If you just work it out from here, you will find all these values. You can work it out straight from this point. So the only thing that is not known is t. Everything else is a number. So you can just work all those out, then you pull them together. If you try to use this, maybe it can also confuse you, this last formula. This is good for theory. But when you are solving, you can just work directly using this one. Anybody? So mmekubali kushindwa?
Yasi. Kidogo.
You need more time. So anyway, let's try to solve it. Here you have, in parametric form, the equation of a straight line will be this. So for you to find the point of intersection, you need to substitute this parametric form into the equation of the circle. So simply, where there's x, you put 2 plus t. Where there's y, you put negative 2t. Where there is z, you put 4 plus t, which is what we do here. And again, you will have some work to do to simplify. Once you expand all these terms and put the like terms together, this should be t, not r. So it should be 18t squared plus 36t. I don't know why I have r. Even this one should be t. This last one should be t, because this is 4 plus t. So this must be 4 plus t. Okay, I think you can do that correction. This should be t squared, and that is r. This r again should be t. So basically, you have a quadratic equation in t, which you can solve.
-1.
Pardon?
It should be -1.
-1. What do you mean -1? T is -1.
Yes.
Okay. So that's correct. So the only solution is, there's only one solution then. If t is -1, then the point of intersection will be x is equal to 2 plus -1 is what? 1. And y will be equal to 2. And z will be 4 minus 1, which is equal to 3. So the point will be 1, 2, 3. So there's only one point.
Yeah.
And that means the length of the chord will be 0. Since there's only one repeated root, this line will touch the sphere at only one point. So if we had two different values for t here, then we would get two separate points where the line cuts the sphere. But now we have only one value. T will be 1. There's only one value of t. That means it's a repeated root for this quadratic equation, and therefore there's only one point of intersect, or where they meet, the line and the sphere meet. And since it's only one point, it means the length of the chord is 0. So kwa hayo machache, we can stop there unless you have some questions. Huh? So I can see you are eager to do the cut. Why don't we do one? Agudis. Umeiva kweli? Naona umeiva bwana.
Bado.
Bado. I will send you some practice questions this week,
Okay.
which you can use to prepare. Then I will. We will organize for a cut. The cut, you will have maybe about a whole afternoon to do the cut. I will put it on Somas.
Okay.
So we can do that next week.
1 week.
1 week is too much, man. Getelo.
3 days.
Eh? Okay, we can make it maybe 1 day. Not. You will have a day to do the cut.
Yes, better.
That's fine.
So that means I must put the very long questions.
You wanna kill us?
No, I think Mwikali agrees.
We want to finish.
No.
She doesn't agree. Okay. What about Ken? Tulete maswali ngumu.
I don't.
No, sorry. I don't agree. Sikuwe ngumu.
Okay. So we'll organize for one next week. The cut, but I will have to. There are a number of questions in the notes. Try to solve those problems in the notes. They will help you practice, but I will try to write some more practice questions and send you. We still have a few more things to do. Hopefully, we can complete the work next week. If in fact by now we would have finished if I wasn't unwell for the last 2 weeks. Or maybe I should teach up to the final week.
No.
But you guys will be too idle, man. You are responsible citizens. You will.
Yes.
Okay. Okay, responsible citizen. Yes.
Assist us with the course outline.
Did I put it on Somas? I'll check. I thought I put it on Somas. If I haven't, I will put it there. Any other question? Omolo, you are very quiet, Bara. You are ready for the cut? Okay, we'll stop there for today. I think there are no more questions. I can stop the class and you can